my channel. Let's discuss chapter electricity NCERT exercise question number 5. How is a voltmeter connected in the circuit to measure the potential difference between two points? We know voltmeter is connected in parallel. This is a resistor and this is how voltmeter is connected. Now question number 6. A copper wire has diameter 0.5 mm and resistivity of 1.6 into 10 to the power minus 8 ohm meter. Diameter is given 0.5 millimeter. Now convert millimeter into meter into 10 raised to power minus 3 meter, which is 5 into 10 to the power minus 4 meter. Now calculate radius. D by 2, radius is D by 2. 5 into 10 to the power minus 4 upon 2, which is 0.5 into 10 to the power minus 4 meter. Now calculate area. Pi r square 22 upon 7 into 2.5 into 10 to the power minus 4 whole square. 22 upon 7 into 6.25 into 10 to the power 4 to the 8 minus 8. Now 22 upon 7 into 625 upon 100 into 10 to the power minus 8. 22 upon 7 into 625 into 10 to the power minus 8 minus 2. 22 upon 7 into 625 into 10 to the power minus 10. Now on solving this, we will get 13750 upon 7 into 10 to the power minus 10. On solving this, we will get 1964.28 into 10 to the power minus 10 meter square. We can reduce this into 1.964 into 10 to the power minus 7 meter square, which is the required area. Now rho is given 1.6 into 10 to the power minus 8 ohm meter. What will be the length of this wire to make its resistance 10 ohm? Resistance is given 10 ohm. We have to find length. We know resistance is rho L upon A. So length is RA upon rho. Now putting values, L equals to resistance is 10 into area that we calculated 1.964 into 10 to the power minus 7 upon rho, which is given 1.6 into 10 to the power minus 8. Now on solving, (1964) upon 16 into 10 minus 7 minus 8 minus 1. 4 4 is 16, 491. On solving, we will get 122.7 into 10 to the power minus 7 plus 8 minus 1. 122.7 into 10 to the power 0, which is 1. The required length is 122.7 meters. Now in question, how much does the resistance change if the diameter is doubled? When the diameter is doubled, old diameter was D. Now new diameter, which is doubled, is equals to 2D. Old radius was R. So new radius will be 2R. Old area pi r square. New area will be pi 2r square, which is 4 pi r square. Now new resistance. Let's check. R dash equals to rho L upon A, rho L upon new radius 4 pi r square, which is 1 upon 4 times of R. So R dash upon R is 1 upon 4. R dash is 1 upon 4 R. Therefore, if diameter is doubled, resistance becomes 1 upon 4 times. 7. The values of current I flowing in a given resistor for the corresponding values of potential difference V across the resistor are given below. These values are given. Plot a graph between V and I and calculate the resistance of that resistor. We have to plot the graph between V and I. So we will take I across y-axis and V across x-axis. I, which is current in amperes, and V is voltage, which is in volts. O is the origin. Now when voltage is 1.6, the current is 0.5. When voltage is 3.4, current is 1. When voltage is 6.7, current is 2. When voltage is 10.2, current is 3. When voltage is 13.2, current is 4. The graph of VI is a straight line graph. We will find the slope, which is change in y upon change in x, which is, we will mark points A, B, C. Point A is 4, point C is 2, this point is 6.7 and this point is 13.2. Change in y, which is AC, upon change in x, which is BC, equals to change in y 4 minus 2 upon change in x 13.2 minus 6.7. We know V is equals to IR. So R is V upon I. So 1 upon R is I upon V. I upon V, which is 1 upon R. 1 upon R is 4 minus 2 is 2 upon 3.2 minus 6.7, which is 6.5. This implies R is 6.5 upon 2, which is 3.2 ohms. So resistance, the value of resistance is 3.2 ohms. Now question number 8. When a 12 volt battery is connected across a unknown resistor, this is an unknown resistor R. A 12 volt battery is connected to it. There is a current of 2.5 milliampere in the circuit. Current of 2.5 milliampere. Voltage is 12 volt across the resistor and current is 2.5 milliampere. We will change milliampere into ampere. 2.5 into 10 to the power minus 3 amperes. Find the value of the resistance of the resistor. resistance is V upon I. Resistance is voltage 12 upon 2.5 into 10 to the power minus 3. On solving, 24 upon 5 into 10 to the power minus 3. 24 divided by 5, we will get 4.8 upon 10 to the power minus 3. 4.8 into 10 to the power 3 ohms. We can write 4.8 kilo ohms. This is the value of resistance of resistor. Now question number 9. A battery of 9 volt is connected in series with resistors of 0.2, 0.3, 0.4, 0.5 and 12 ohm respectively. How much current would flow through the 12 ohm resistor? There are 5 resistors connected in series with a potential difference of 9 volts, which is 0.2 ohm, 0.3 ohms, 0.4 ohms, 0.5 ohms and 12 ohms. How much current would flow through the 12 ohm resistor? Equivalent resistance. Since they are in series, the equivalent resistance will be 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12, which is equal to 13.4 ohms. Since they are connected in series, so the current in circuit will be equal to the current in 12 ohms. The same current will flow through the whole circuit and the same current will flow through 12 ohm resistor. So the current is in circuit, which is V upon R equals to 9 upon 13.4, which is equal to 0.67 ampere is the current through 12 ohm resistor. Current through 12 ohm resistor is 0.67 amperes because there is no division of current in series. Therefore, current through 12 ohm resistor is 0.67 amperes. Now question number 10. How many 176 ohm resistors in parallel are required to carry 5 ampere on a 220 volt line? Let n resistors are required which are connected in parallel. In parallel, R equivalent is 1 upon R1 plus R2 and so on. So 1 upon 176 plus 1 upon 176. These are n times since we have taken n resistors. N times of 176. So R equivalent is 176 upon n. Now by Ohm's law, V equals to IR. R is V upon I. R, which is 176 upon N, equals to voltage. Voltage is given 220 upon current. Current is given 5. 5 into 44. N equals to 176 upon 44. which is, so n equals to 4. So 4 resistors are required in parallel, which are connected in parallel of 176 ohms.